So, Justin, yes? This is how I learn names. Justin, during this course, we're going to use models, approximations, often mathematical, to help us understand something. If you are good at math, you'll find this course a pretty easy B and a doable A. If you're not that good at math, by the end of the year, you will be far better at math than you thought possible. I am big on pushing you out of your comfort zone. I am big, Brandon, on trying to get you to solve stuff in your head. Never on a test. You're going to hear me often say, on a test, I'll show all my work. But in your homework, if you can become expert enough to do a lot of it in your head and only show 1 or 2 lines, I'm good with that. Oh, because I always give you the answers. You'll check. If you got it wrong, then you'll say, oh, I guess I can't go that fast. I'm not expert enough yet. You with me okay there? But I have to, even though we're going to be using models to approximate universal or particular set of phenomena, I have to start up by saying these models will almost always be wrong. Well, you know what? Cross out the word wrong and you can put incomplete. I can, Trevor, if I want to, continue all the way down in every explanation down to atoms and nuclei and protons and neutrons and quarks. Nathan, we're not going to do that. But not only that, sometimes we're going to ignore stuff because the math is yucky. We'll look at projectiles, we'll ignore air resistance because you need calculus to solve it and the math is yucky. We'll look at ropes and pulleys, except our ropes and our pulleys won't have any mass because you need calculus and the math is yucky. So we're going to be close. We'll be pretty good. Sometimes, once in a while, we will be bang on. I'll try and tell you, hey, this one's good. But gotta be honest, most of what I'm showing you is close. It's an approximation. But since our models are mathematical, we need some math skills, and here is the first one, scientific notation. We're going to be dealing with really big and really small numbers, and that's where scientific notation comes in. We won't use scientific notation as much this year. It'll be an occasional issue. Physics 12, absolutely, we'll be using it an awful lot. What are the rules for writing a number in scientific notation? The first rule says this: there can only be 1 digit to the left of the decimal. As an example, 12.3 times 10 to the 4th is or isn't in scientific notation. Is not. I'll cleverly circle is not, isn't. If I wanted to write it in scientific notation, it would be 1.23 times 10 to the 5 or 3? 5. If I wanted to write it in what we call standard or expanded form, it would look like this. 1, 2, 3. Most common mistake, kids see the 5 and they say to themselves, self, that means 5 zeros. It does not. It means 5 places, 5 spots, and after the 1, and I've already used 2 of the spots up with the 2 and the 3. So the exponent is 5. I've written a 2 and a 3. How many more zeros do I need to write so that we get, Caleb? 3. Okay? So the first rule for scientific notation is 1 non-zero digit in front of the decimal, no more, no less. It can be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. The second rule gives you the exponent. You count the number of places the decimal moves. If the decimal point moves to the left, that way, the power of 10 will be positive. I told you already that I tend to abbreviate, yes? The word positive is too much writing. Except I don't like making that the abbreviation for positive, because to me, that looks like a plus sign and it looks like an equation is missing. Nate, this is my own invention. My abbreviation for positive is a plus sign with a VE, and I read that as positive. If the decimal point moves to the right, the power of 10 will be negative. Guess what my abbreviation for negative is? Negative. Come up with your own shorthand that works for you, Kat. I'm fine with that. Bold font and stars. It is very important that you learn how your particular calculator handles scientific notation. Many calculators have different quirks. First, though, before, Nate, you reach for your calculator, we have to be able to handle doing scientific notation on our own. So here is an example. The Earth weighs that much. That much. I don't want to write that out. I want to write that in scientific notation. Is this number a really big number or a really small decimal? That's meant to be an obvious question. Big number or small decimal? Loud and proud. Big number. I'm going to ask you the same question. I'm just going to phrase it differently. Is my power of 10 going to be a positive exponent or a negative exponent? Positive. Are you positive? No, no, okay. Tough audience. What am I going to write? First digit? Point? Any non-zero digits? Times 10 to what? Well, right now, originally, the decimal invisibly was right there. And I'm going to move it to right there. There are shortcuts, but when in doubt, I get my pencil out and I start doing loops and counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I think I counted wrong. It's 24, isn't it? Yeah. To the 24th kilograms. Kevin, are there shortcuts? There's times when you can like add threes, but you figure them out yourself. When in doubt, always works. Come up with your own shortcuts. 5.98 times 10 to the 24th kilograms. What is that as a real number? You know what? I think last class I said it was 5.98 heptillion. Million, billion, trillion, quadrillion, quintillion, sextillion, heptillion. Whatever. It's easier to say 5.98 times 10 to the 24 kilograms. We also have to deal with some really small numbers. This is the charge on one proton. These two numbers, example 1 and 2, you'll use an awful lot in Physics 12, by the way. Is this a really big number or a really small decimal? I'm going to ask you the same question. I'm just going to phrase it differently. Am I going to have a positive exponent or a negative exponent on the power of 10? Okay. So, am I going to write 6.1 or 1.6? Ooh. Yeah, always we read this way. So it's going to be 1.6 times 10. And I always put the negative before I even start counting because I'm stupid and I tend to forget. That never happens. So the decimal originally is right here, and it's going to end up right there. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I get to the negative 19 coulombs. Abbreviation for coulombs is a capital C. By the way, get in the habit of putting units next to answers. I'm fussy on that. Sometimes, Mitra, they will give you a number written out in English. The temperature of the sun is 15 million kelvins. What? 15 million kelvins. What? Kelvin. What? My name's, no? Okay. My name's Kelvin. I'm actually a science student. First thing I would do is I would write it out in standard form and then I would convert to scientific notation. Okay, that's a lie. I'm good enough. I can convert this to scientific notation in my head without thinking about it. But until I got that good, I would go like this. 15, I got that part okay. Million, how many zeros is that? Now you might know how many zeros that is. If you're not sure, no. Nope. 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 Oh, there, 15 million. Just add zeros. Okay. How will I write that in scientific notation? 1.5 times 10 to the? Good. I heard somebody whisper 6. Do you see why they accidentally whispered 6? They weren't counting decimal spots. What were they counting? Zeros. And it's not counting zeros. You have to count how many spots it moves. And the decimal moves from here to here. 1, 2, 3, 4, 5, 6, count them, 7 degrees Kelvin. 7. Oh, 7. Not only, Spencer, should you be able to go from standard form to scientific notation, you should be able to go from scientific notation to standard form. So it says, rewrite in standard form 5.4 times 10 to the negative 7th meters. Okay. Is this going to be a big number or a small decimal? How do you know? Okay, so I'm going to start out by going 0 point. Most common mistake here, kids look at the negative 7 and they say, oh, it's going to have 7 zeros. Is it going to have 7 zeros? No. It's going to have 7 spots. 1, 2, 3, 4, 5, 6, and then the 5, there's the 7th spot, followed by the 4. I think you have done some scientific notation in like Math 9, and some of you, if you've done Chem 11 already, if you're in grade 12, you've definitely done scientific notation in Chem. Turn the page, or next page over. Is it next page over? Next page over. So now we're going to go to our calculators. It says this. Write down the procedure for entering the number in scientific notation on your calculator below. I'd like you to put your pens down, and I'd like you to put your calculators down, because the first thing I have to show you, which is the most important, is how you will not type it. In order to type 6.23 times 10 to negative 5, this is what I will not do. I will not type 6.23, hit my times button, 10, hit my to the power of button, negative 5. I will not do that. It'll look right on your screen. The problem is your calculator won't treat it right. Your calculator won't know that this part and this part are attached to each other. And so it will behave strangely when you square things or square root things or divide things. It won't behave the way you expect. But here's the beauty. Doing it right is way less work. It turns out, Ross, every one of your scientific calculators has a scientific notation button. And that button replaces the times. You never need to hit it. Replaces the 10. You never need to hit it. And replaces the to the power of. All you are going to type is 6.23, hit your scientific notation button, and then negative 5, which leads to the question, what's my scientific notation button? Now you want to pick up your calculators. For some of you, your scientific notation button will be an EXP. It'll be the bottom row or right above the 7. No one noticed. For some of you, if you have a TI, your scientific notation button will be a capital E and a capital E. It may be a shift button right above the 7 or the 8, or 2 above the 7 or the 8. Some of you will have a times 10 to the blank button. If you have that one, I think it'll be bottom row middle. If you cannot find your scientific notation button, now is the time to call me and I will come help you. I'll pause the video. So in order to enter 6.23 times 10 to negative 5, you can write this down in your notes. You will enter the 6, the point, the 2, and the 3. And now you'll hit your scientific notation button. On my fancy schmancy graphing calculator, mine is a little yellow EE right there. So I'm going to write in my notes EE. You'll put in your notes whatever your button is. And then negative 5. And you can try typing that in. It's going to look like on mine 6.23, that, -5. And the reason you want to try typing it in is you also want to see how your calculator displays the times the 10 to the power of. Mine and the TI's puts a capital E there. And that's because that's how it's done on computers, and more calculators are moving to keyboard computer notation. Those of you that have the times 10 to the button in the bottom middle, it probably actually puts a times 10 to the, and even moves you up into a little exponent. That's fine too. If you have a really crappy calculator, it'll just leave a space and put a -5. Everybody got that okay? And if you hit enter, it should just repeat the number. If you get a syntax error, let me know. Enter or equals, store it. We're all good? Another comment. Look up for a second, my angels. That's a negative. That's a negative. That's a subtraction. So all of your calculators distinguish between a negative number and subtracting. Your subtracting buttons, all of yours are right there. Your negative buttons are probably either there, or some of you might have it kind of in this area somewhere. But make sure you don't get them mixed up, because if you put a negative where you meant subtract, or you put a subtract where you meant a negative, you'll often get a syntax error. Usually, if you have a good at calculator and you get an error, if you go left arrow or right arrow, the cursor will appear right where the error occurred in your typing, and you can try and figure it out. I went on my rant about getting a good calculator at the beginning of it. You guys didn't hear. I went on my rant. Yes, there's a reason for all my madness. Is that all right? Okay. So let's actually do some math with this. Performing calculations. Example 1, example 2. Some comments. What mathematical operation does a long fraction bar mean? Adding, subtracting, multiplying, or dividing? Dividing. I will never use this symbol for division, and the reason is, Felicie back there, that looks too much like a plus sign from far away. Too easy to mistake. Okay? So I will always, if I'm typing, show dividing by that, or a slash if I can't fit it on 2 lines. All right. So, Mitra, we're going to play some yes and no questions. Are you ready? Is this a fraction? Is there more than one thing on the top of the fraction? That means I'm going to put the top in a big bracket. Is there more than one thing in the bottom of the fraction? I'm going to put the bottom in a big bracket. However, these 2 touching brackets, what do 2 brackets side by side like that mean? Adding, subtracting, multiplying, or dividing? I'm going to just replace them with a times. I'm not going to put close bracket, open bracket. I'm going to replace it with my times, because typing on a calculator, too many brackets is confusing. Typing here like this, more brackets is clearer. So all of us, this first one, we're going to type together. Get your calculators out. Mitra's going to walk us through this. Mitra, is there a fraction? Say yes. Is there more than one thing on the top? I start with an open bracket. I'm going to go 1.8. I'm not going to type times 10 to the. I'm going to hit my scientific notation button. Mine looks like that, whatever yours is. What's the exponent on the 10? I'm going to make sure I use a negative, not a subtraction. 3. And I've entered that first term. 2 brackets kissing like that. What mathematical operation is that? So I'm going to hit the multiply. My multiply on my screen looks like an asterisk, and that's because on a computer screen, that's the times key. Yours might look like an actual times sign. The next number, 2.6. I'm not going to type times 10 to the. I'm going to go 5. Mitra, have I reached the end of the top? Close off the bracket. That tells my calculator all of that is on the top. What did we say a long fraction bar means as a mathematical operator? Division. I like on my calculator, if I hit divide, it actually puts a slash there. More and more newer calculators are doing that. They're recognizing the old divided by sign looks too much like a plus sign. It's stupid. Is that okay? Sydney, is there more than one thing on the bottom of this fraction?
Say yes.
I better have a big open bracket to tell it this is all in the bottom. 9. scientific notation button 8. 2 brackets kissing. I'm just going to go, I'm not going to close off. By the way, if you close off the bracket and now you do this, you've just told your calculator that the bottom ends there, and it's going to assume the next thing is on the top. That's why I don't like opening, closing brackets in the middle of a bracket. So I'm going to just put a times there. 1.3 scientific notation button, -1. Mackenzie, have I reached the end of the bottom? Close off the bracket. And if you do that and hit equals, you should get this. Or maybe not. You might get 4 times 10 to the -6. Your calculator might go 0.0000005 zeros and then a 4, because that is 4 times 10 to -6. Or your calculator, how many of you got a fraction 1 over something 125,000? Okay. Do you know how to go from fraction to decimal on your calculator? Okay. Pause the video. I'll come show you. The answer is 4 times 10 to the -6. If you wrote 4e -6, I wouldn't take marks off, but remember that e is a replacement in computer speak for times 10 to the power of. And you know what I'll do for you guys, because I can, it's kind of cool. If I go clip, I can actually go paste that right in there and show you what I typed. Isn't that nice, huh? Hey, huh? Hey. Ooh, oh, you, boy. Braden. Oh, that's refreshing. Okay. Next one. If you glance at example 2, where is the curveball? What's weird? What's different? Yeah? Okay, the exponent. I got an exponent on scientific notation. Is this a fraction? Yes. Is there more than one thing on the top? Yeah. Well, let's start out same old, same old. I'm going to clear my screen. Bracket. This is a chance for you to follow along, see if you can pull up this one. 5.8 scientific notation button 3, 2 brackets kissing. I replace that with times. 2.67 scientific notation button 21. Close bracket. What's a fraction bar mean as a mathematical operator? Division. Divided by. Is it more than one thing on the bottom? Yeah. By the way, whenever there's a fraction, if you put the top in a big bracket and you put the bottom in a big bracket, that will never be wrong. As the year progresses, you'll learn when you can get away without the brackets, and I'll sneak that in. So some of you are saying, well, Mr. Duick, I don't know if you need a bracket. There are certain situations where we're fine, and we'll get there. If some of you have calculator experience enough to know when you need to and when you don't, we'll get there. Okay? Open bracket. Negative, not subtraction, negative. 9.24 scientific notation button, -3. And I want to put all of that to an exponent. So I have to find my to the power of button. Now, your to the power of button is not exp, even though exp sounds like, doesn't that sound like exponent? On most of your calculators, you'll have a button that looks like this. It's a little carré. It looks like that. It's the Shift 6 on a keyboard. Most of you will have that. Some of you will have a button that looks like this. All of you need to find where your to the power of button is. And if you can't find it, now I'll come around and help you. So if you're wondering what this works out to, and then times 1.3 scientific notation button -1, you'll get that. Now, my calculator rounded off the 7. Some of you may have a longer display. I think it actually goes 6, 8, something. Some of you may have an even longer display. But I'm going to write -1.77 times 10 to the 36. Mr. Duick, what do we round off to? There are rules for rounding off, and that's the next lesson. It's called sig figs. In this example, that's 2 sig figs, that's 3 sig figs, that's 3 sig figs, that's 2 sig figs. You would go to 2 sig figs. There's a whole procedure, and you get pretty quick at it. But for now, I'm going to round off to 3 well, to 2 decimal places, to 3 digits. So I'm going to write negative 1.777, because there's an 8 next to it, times 10 to the 36. How many of you got that okay? Since most of you did, I'm going to get us all started on the homework, and then those of you that had questions with the weird calculators, I'll show you how you can make it work today, or if you want to, I'll swap you for a better one today and walk you through it. But first, let me go cleverly like this. I can go copy. Ooh, isn't that cool? So you got 2 pieces of homework. First of all, there are questions attached here. Normally I attach the answers. Did I attach the answers this time? No, because I'm going to put them online and I'll go over them next class. But 90% of the time I attach the answers to stuff. And then I have one more little handy dandy lame sheet. Give me 1 second.